$2, $3. Also, one very important point is that I'm doing an exit with an exit code, okay? If you are building a command line interface, the odds are extremely great, if you have a published command line interface like AWS or Heroku or anything like that. The odds are incredibly high that somebody's going to use your command line mechanism within their own process. So, their process is calling your process. Their process doesn't care what you spit out and standard out. Their process cares about the return code, okay? The exit code that you give back is what a human won't see that, but that's for other processes to say, okay, the userman process created a user. I should be able to now, if it's some automated process, I should be able to go do another thing, look up a new user, whatever, knowing that that passed, or I got a non-zero response back, I know that it failed, and I should be able to take some other path. Always. That is as important, or more so, honestly, than writing a statement that says, yes, user created, or yes, the thing did. That's for humans, and you really need to do that. But this is kind of a must, okay? Because if you don't do that, nobody would know, like another process wouldn't know whether the thing worked or not, right? So let's run this. This is, all right, we're going to say, and we're going to pass in what roses are red, violets are blue, and we're talking about argv. So I parsed the argv and you can too. So let's look here in our terminal output. We can see that it tells us there were 3 args passed. So red, blue, and argv. Arg0, remember how I said the 0 space in that array is always the thing that was called. Now, if we put this file in our bin, okay, it's called first CLI, and then we just node up a terminal. From anywhere else, we just type first CLI and then pass in arguments, okay? So you want to make sure you name things well, right? But in this case, argument 0 is the actual path to the file that we executed. Red, blue, and argv. And then we have our poem. Roses are red, violets are blue. I parsed the argv, and now you all can too. Okay, so that one is easy. Let's go one step harder. Again, we have our directive, I've been bashed. I'm going to go through this one kind of quickly. All right. Now we have variables. So what if I don't want to just positionally, or what if I don't want to just do $1 and then 200 lines down, have to remember, turn lines down, have to remember what was $1 versus $3. Madden, right? So we do what developers do. We create variables. Roses is $1, violets is $2, parse is $3, which again are positional arguments in the vector. If our roses are empty, again, why 0? Maybe it's 0 length. I honestly don't know, but it is what it is. If roses is empty, then I have some defaults. Roses are edible, even though I don't think they are, so don't try that out on kids. If violets are empty, violets are stew. I just made up stuff, don't judge me. If parsed is empty, parsed defaults to dinner. And again, we have our fi to end our if. I just love that. And so here we echo. Notice you don't really have a notion of paragraphs. So if you're used to like writing HTML and you can just do a p tag in all the lines, no, you can't do that here. You have to echo every single line. So if you want things to line up a certain way, yeah, you're manually doing that. Have fun with that, bud. Okay. So we're going to do 0, 2. And we'll pass in no arguments. So here our defaults kicked in. Roses are edible, violets are stew. I parsed the dinner and you can too. Okay. But if we did red, blue, and argv, then it uses what we passed in. So if this were an app, right, it'd be like, oh, you just use variables, no big deal. But in a command line interface, it actually is a little different. It's interesting, I think. So let's go one step harder. is 4 steps probably. But I kind of have to, you know, get some meat into it while we're here. Let's look at another fun symbol. $@. Okay, so this $@ just means give me all the args, and it knows, it is smart enough. Again, these kind of idioms that they had to create, probably just because of space constraints and memory constraints and things like that. It is smart enough. They probably get tired of, frankly, of like looping through everything from 0. It was like, I just want to start at 1. So the $A is smart enough to say, exclude the 0 one. So it's everything after what was called, because your code is running, your code knows what was called. It was called. It's me. Yeah. So now let's look at some functions. All right, I have a function called getHelp. We have to echo out every single line. We have to space it appropriately, or however we want, I mean. So if we want to print out some usage, here's how we do that. And it's obviously lots of fun, and not tedious in the least, and changing commands and arguments would not be obnoxious at all doing it this way. I'm obviously being a little facetious, but, oh, and then I have a note here. Because it's text-based, okay, space is limited. Normally, like in my terminal, normally I have a quadrant, or I have 4. I split my terminal into 4, and I normally have a different area that I'm working on in each one. So you literally have about a 3x3 section on this laptop. On my smaller laptop, maybe less, maybe 2 inches or 2 inches or whatever. Don't print out huge headers like that. I'm doing that for fun. This is a demo, and you know, whatever. You probably don't want to do that. All right. I have another function, getGreeting. Okay. You might think, oh, he's referencing $0, $1, $2. That's going to be the arguments that were passed into the command line. You would be mistaken, as I was. Functions in Bash have their own scope. Now, they don't get a new set of variables. So if you didn't alias $1 in the outer scope, in the inner scope, you can't access whatever $1 was in the outer scope. So if you want to know, okay, what they passed in for that argument in the outer scope, nope, it's gone. When you're inside a function, you get your own scope. So maybe there were 4 arguments in the outer scope, $1, 2, 0 through 3. In the inner scope, $0 through 3 may not be anything. Maybe there were no arguments passed to the function. Maybe there was only 1, so now you only have $1. Because $0 of a function is still, I think, the name of the script, I think. We'll find out in a minute. So, always alias your $vars to actual variables that you can access from within a nested scope. You can also do things like local. So if I had an outer variable named name, I could say this is a local variable named name. Now, all that lets you do is say I just want to call this thing the same thing, but I'm not going to ever access the one on the outer scope. So I can't get it, and I also can't set it, right? Again, we're using the Z syntax. Okay. A function called and it does a critical error. It does some echoes. You've seen that $@ syntax, so we'll do that in a second. Oh, another thing, when you call functions, it's like this. You notice I'm not invoking it. There's no parentheses. So that's nice. Yeah. Exit 1, so this is a failure. It's a non-zero exit code. Okay, so in all these demos, I try to make sure that I practice the thing that I'm talking about here, and yeah. All right, so here, we're also calling a function. Anybody remember that function we looked at a second ago called Okay, the way you have, because it's all strings, you just name the function, and you pass in a set of strings, and those become the arguments, the argument vector that goes to that function. Okay, nice. So let's take, I don't want to go down any further and ruin a surprise. So let's take a look at this. So I'm going to just execute 0 to 3 with no arguments. And I got an error. At least 1 flag is required. Well, okay, what's our usage, our help block? So remember, in that we had to manually call getHelp. So if we wanted to do help from somewhere else, we would have to manually call getHelp. So if I did the same thing, I passed in H for help. Notice that there's no error now. It just goes right to the help. okay? So let's zoom down real quick, and I'll show you how that part is happening. Pretend you didn't see that. There's a function here called parse args. Now, notice that I had aliased all args as an array earlier. Otherwise, in here, if I try to access $0, $1, it would not be what we would think it would be, because this is its own scope. So what I'm doing is I'm saying, and this is a dead simple command line, I'm saying I'm expecting the thing you want done to be an argument 0. That's it, right? Because remember that $app characters, it excludes the thing being called. So the 0 index in this case is whatever we passed in the flag. You can have a flag of -h or --help, and this is how we're doing basically regular expression checking. Okay? So here I'm calling get help. I'm doing x0, double semis to end the case, because this is a case statement, or if you're used to a switch case, this is a switch case without the switch. We're doing another one. Now name is interesting, because name, I want to support passing in --name equals some value, or just -in space some value. So we do some fun stuff there. We grab the first index, because you pass in name and it's some value, as your thing here. If we don't have a value, and so if you passed in -in space some value, we would have an index. We'd have a value at index 1 of the arg vector. Okay. If you did that, then name would be populated here. If you did not do that, and we are testing, or regular expression testing here, that our arg0 is --name equals, and then anything, then we have to do a whole other regex thing here to parse that out and basically say, I want everything after the equals. Okay? And to be honest, whenever I'm doing anything in Bash, I just have to go look stuff up, because I don't use it often enough to like memorize this stuff, so I wouldn't try to memorize any of these things. Just know that they're there, and just know, oh, okay, if I want to get all the arguments, I know that's a thing, and I can go look it up. Or if I want to split something on an equal sign, I know that's a thing, I can go look it up. Now, we're calling that get greeting function, and we're passing in the name. So now it has its own argument vector, as we talked about, and argument 1 will be name. Okay, cool. Anything that we don't have a case for, it goes to the unrecognized parameter. So we can test that real quick. We can say, I don't know, I don't think we have anything on like K. Okay. So it gave us an an error, unrecognized parameter K. Okay. So let's do the greeting thing. So we're gonna pass a name of chick. Cool. The get greetings arg, 0. So 0 here. Oh, little tooltip blocking away. The 0 value is the name of the thing being called, the script being called, the file. It would be the executable if this were symlinked or whatever. The actual first argument was just chicken. Even though, so it happens to be the same here, even though we could do it this way. Name equals chicken. So there is no additional argument. Oh, I passed in one dash instead of 2. There we go. So we only passed in one argument to the outer scope, but in the inner scope, it got only one argument too, but it was scoped down, or it was split down to just the chicken part, just the part we cared about. Okay, cool. So what if we want to just explore that last thing? What is it, monkey? So you can do ASCII art, you can draw a monkey. And then I took all the monkeys from, or any ASCII art from ASCIIart.eu, and I attributed them. Okay. What if I don't want to do bash? Join the club. Oh, again, and then here, instead of like in case, it's just ESAC, case backwards. I love it. The last thing we're doing here is parsing our args. So if you notice that with bash, like things literally go top to bottom, okay? In a lot of programming languages, we kind of tend to structure things top to bottom, but things don't really work that way. In JavaScript, you can, depending on how your linter settings are, you can call a function up here, and it be declared down here because it's JavaScript. In Go, you can actually do, because it's compiled, you can Go has a notion of modules, and you have two different files in a module, let's say, and they together kind of make up that module. You have a function declared in this file, and you can execute it in this file, and it knows how to compile it so that it's not executing before it's defined, okay? So we don't have to necessarily adhere to that, but with bash you have to adhere to that. I could not have called parse args right up here above it being defined. It would have broken, okay? All right, so I don't use bash. I don't care for bash. What if I want to use node? And how are we on time? So let's look at a quick example of node. First off, let's just look at my file structure. So this is going to be more in line with kind of what you're used to seeing in a program. You're used to seeing maybe a main or a node has an index. You're used to seeing maybe some utils, or in this case commands. That these are the individual commands that my utility supports. So it's very easy to look at and reason about. Maybe I have a util called logger. Okay, cool. So what logger does, logger uses a utility called chalk, and it allows me to do things with like a blue background with bold white text, and if your terminal supports the colors. And as a fun homework assignment after this talk, look up how you do colors in the terminal. It's a whole bunch of weird symbols and things, and you basically say start this color in this background with these symbols. You type in whatever text you want, and you have other symbols to say stop doing that. It's these interesting directives that you have to give kind of like in line. All right. One of the coolest things, in my opinion, with doing a node-based command line interface is a utility called yards. And yards, if you look at their website, is a pirate-themed. It's beautiful. I mean, the kid in me just loves it, right? So it's a pirate-themed utility that lets you build command lines with Node.js. Now look at this syntax. Look at this. Look at how this is laid out. So I just say, and again, I call it argv because I know what it really is, right? Let argv equals yards, and then I'm saying .version, .script name, and then .usage. So that usage, like the top of the help block where I pass in, where I tell it usage, that's what I need to do here. I just tell it the usage. I tell it whether or not I want to show help on fail. I'm telling it false. A lot of help blocks are massive, okay? And just because a person accidentally mistyped a thing and they know what they're doing, I don't want to clutter up their terminal every single time. So I want them to explicitly type help. But if they type in something that I don't recognize or I can't do, I do at least want to tell them, hey, something went wrong. There again, that type feedback loop. Something went wrong. Specify help for available options. It takes up one line, and if they already knew that they fat fingered something like we all do, they can just go on about their day, and they don't have to scroll all the way back up to copy and paste what they just tried to type in if it was a long thing or something. Okay. You can even do like .help. You can tell it something else. Like if I wanted you to type in helpful or get help or SOS or any other thing, you can do it there, and they would basically just look for that. They're building the parsing on the fly, and they're also building the help block on the fly, so it's pretty cool. All right, I'm telling it to wrap the text at the terminal width, which is a whole set of things, but you can look that up. This is again just to kind of get your feet wet, but it'll try to determine the terminal width and wrap the text accordingly. And here we go. Now we can define commands. I have two commands. One is anything. Any command that is not known, I'm going to default to this one. Now, as you know, you can't just have a function that is the default and just always gets executed without having some kind of gatekeeper type constructs or validations. This default execution will always work as long as we have this name property or option, or whatever you want to call it. If you don't pass that, then obviously this command will fail because I have the setting demand option true. So what this is, I can define the options for the command. The key is just a key value pairs. The key is the name, the big name, the full name of it. The value is an object describing what this option does. It also allows you to give an alias. So if I want to just type -n, instead of having the user type -n equals blah. Okay, and then I can describe it, the name, to direct the greeting at. Or, if you're passing in drawski as the command, I can also give an alias, I can describe what it does, and I can even restrict that to certain choices. So Yards has built-in validation. I don't have to go write a thing that says parse out the thing, and if iterate now in bash, you saw that iterating is not exactly fun, and regexes are not exactly fun. I don't have to do that. I can just say, hey, Yards, here's the choices. You do it. Demand option, true. .help, so what this does is this says, go ahead and if they passed in help, just go ahead and execute. I don't know. I might be wrong. I don't know what it is if you call .help in the chain. Oh, okay. Implicit command to display. Actually, I may not need that because I did the help up here. So we can remove that. Sometimes you find mistakes in live coding, and that happens. Okay. So this is pretty nice to work with. Even if I had complex things, so you could do nested commands, and you can look that up as needed, but you can do even nested commands. So if I said, hey, I'm going to have a suite of commands at the user, I'm going to have my thing, user, and then maybe the suite of commands are the verbs. Create, update, get, whatever, right? So like something bigger like AWS, I'm going to keep referring to them. That's the kind of scenario that they have.